All right, here are our solutions to perfect problem 1 for Math 243. We're given a bunch of data. I guess these are grade point averages, high school grade point averages for a bunch of college students, and asked to do a few things. First, to create a stem and leaf plot. I don't know if all these hyphens are necessary. When you're making a stem and leaf plot, what you want to do is the last digit in your number will be the leaves, and the rest of the digits will be the stem. So my stems will range from 0 up to 4. So I'll want 0, 1, 2, 3. That was supposed to be a 3 and a 4. And then throw a line down here. It's important that you include 1. You're like, but nobody had a GPA of 1 point something. It doesn't matter. We have a 0, so we want to put a 1 in between the 0 and the 2 to really emphasize the shape of this thing. And then you go through and you just put on in all the leaves. 0.8 means throw an 8 right here. There were nothing in the 1s. 2s, I have a 2.0, 2.1, 2.4, 2.7, 2.8, and 2.9. 3s, I had 2 3.0s, 2 3.1s, 1, 2, 3 3.2s, 1 3.4, 1, 2, 3, 4, 5 3.5s, 3.6, 3.7, a couple 3.8s, and a 3.9. And then 4s, I had 5 people with a 4.0. 1, 2, 3, 4, 5. So this right here would be my stem and leaf plot. Okay, good enough. Use your calculator to sketch a histogram of the data with bin lengths of 1, then another one with bin lengths of 0.8. Okay. I think the worst part about that is entering all this data into your calculator. The way you do that is you hit the Stat button, then you go under Edit, and you want to put them all in a list. I didn't think you wanted to watch me type all these in, so I put them all in already. If you need help with entering data into a list, I have a separate video on that. But I've already put all these numbers in this list. You can kind of start to see them as I scroll down here. Hopefully I put them all in correctly. Whoa, I didn't. That should be a 3.6. Hopefully that's the only thing I screwed up. It's supposed to be 30 observations. It's asking me for my 31st. Okay, that bodes well. And now I want to make a histogram. So the way you make a histogram is you go under Stat Plots. First stat plot is for a histogram. Turn it on if it's not already. And select the one that looks like a histogram. And then tell it what list your data is in. My data is in L1, so I don't have to do anything. But if you had it in a different list, you'd hit second, and then whatever number, like if you had it in L3, you'd hit 3 because this L3 is above the 3 key. Mine's in L1, so I'll leave it like that. Frequency, leave that alone. Then hit Window. And what you want to do is specify the endpoints. My GPAs go from 0 to 4.0, so for the minimum I'll put 0, and for the maximum I'm actually going to put 5, because that last bin will go from 4 to 5. And if I want the bin length to be 1, I'll put a 1 here. When I want it to be 0.8 later, I'll put a 0.8 here. For Y minimum, I like putting -1 in so I have a little bit of a border around my observations. For Y maximum, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, something like that. There's a lot of observations on this third bin, so let's make it maybe 20. Number a little bit more than the maximum observations in any bin. And then leave the rest of the stuff alone. So now if I hit graph, it should spit out a histogram for me. There it is. So I make my histogram over here. I said sketch, so it doesn't have to be super approximate. We got 0, 1, 2, 3, 4. And we'll actually need all the way up to 5. And it looks like we have just one observation over here, none in this one, a few here. Let's see, a little even more here, and then a few out here, but a little bit less, so there-ish. If you want, you can put the scale over here for the counts, kind of how many are in each of them. I'm going to be lazy. I'm going to say sure. There's 0, there's 10, there's 20. You can ballpark the rest of them. This was like 19, I think. Good enough. There's one histogram. Here's my second histogram. See, for my second histogram, I want the bin lengths to be 0.8. So I want to go from 0 up to 0.8. And then from 0.8 to 1.6. And then from 1.6 to 2.4. I need a little more room. From 2.4, I want to go to 3.2. From 3.2, I want to go to 4.0. And from 4.0 up to 4.8. So it'll be the exact same idea, except now I go into StatPlot and I reprogram this first one. No, I don't. Actually, I could have left all this the exact same. I guess we're still using the exact same data, so I don't have to do anything in StatPlot. All I have to do is hit this window key right here. And if you hit window, what will change is our X maximum. You could leave that at 5, but maybe just so it matches up with the picture, I'll make that 4.8. But really the important thing that changes is that our X scale is no longer 1, it's now 0.8. But really that's the only important change you make there. And then if you hit graph, it'll show you a new histogram. And this new histogram looks a little bit different. Same basic shape. There's a few more here. And even more in this next one. And even more over here. And then a little bit less somewhere in here for this last guy. And again, you can make a scale out here if you're interested. If you hit the trace key, it'll tell you exactly how much are in each bin. So like this big bin here had 14 in them. So I don't know, I can keep my same scale, I guess. 20 is way up here. 10 is somewhere in here. So 14 is a little bit more than 10. This guy had 8. So this guy's a little bit less than 10. I don't know. Roughly speaking, here's a histogram. Use your calculator to make your histograms. Did it. 3. Comment on the shape of this data. Don't think it really matters which one you look at, although I think this is more clear. You can either look at your stem and leaf plot, this histogram, or this histogram. I would say that the data appears left skewed. Do you want to write more about that? You don't really have to. The reason why, I'll say note the tail pointing to the left. Right, this guy's kind of got this tail out here to the left. Same idea there. So I would say the data is left skewed. Calculate the mean, median, and mode of this data and comment on which measure is most appropriate to use in this example. Okay, fortunately the calculator can do all that for me. If you hit the stat key, then you go to calc, one variable statistics, and then I've already put all this data into L1, so I just hit enter, and what it'll tell me is that the mean, maybe I'll write it this way, for the mean, it's x bar, which is equal to 3.24. For the median, we'll use the letter M. Your calculator says MED. We can find that if we scroll down a little bit. There it is. Median is 3.45. Note the mean is less than the median. That's what we typically expect when we have left skewed data. The mode, kind of the dumb one. It's just which one appears most frequently. 3.5 occurred 5 times and 4.0 occurred 5 times. So for the mode, we're bimodal. You don't have to write that. And it's bimodal maybe at, sure, 3.5 and 4.0. Mean, median, mode. Let's see, if our data is skewed, we want to use median. Median is best measure. Because the data is skewed. Maybe I should number these a little bit. It's going to be a pain for the graders to follow. Here's part 1 here. Here's 2 here. Was 3 just comment on the shape? Yeah. Here's 3 here. Here's 4 down here. Maybe I can do 5 over here somewhere. Part 5 says, calculate the range, the variance, and the standard deviation. Fine. Range. It's just min minus max, or is the difference between the minimum and the maximum. It's the maximum minus the minimum, which you can either look at your data or in your calculator here. It's saying the maximum is 4 and the minimum is 0.8. So my range is 4 minus 0.8, which is 3.2. I think I'll do standard deviation next. Standard deviation, we use the symbol S. It's a sample standard deviation. And we can get that straight out of our calculator here. It's this SX thing. It's point, I don't know, maybe I'll do 3 decimal places, 0.717. And finally, the variance. For the variance, we use the symbol S squared. And to figure it out, we can just do this number, this 0.717. I don't know. If you're being really careful, I guess you could put in more digits, 0.8222105. Although you don't really have to type all those in. Squared. We'll square that to get our variance. If you square it, you get 0.514. If I round this off, I get 0.514. So that's my variance, range, standard deviation, variance. I believe I got everything. I do. So that's the end of this problem.